Hi everyone, today I'm giving my presentation topic with carbon nanotube FET. So let us begin with some introduction of the carbon nanotube FET. Carbon nanotube field effect transistor (CNT FET) also represent a promising class of molecular electronic device that utilize a carbon nanotube (CNT) as the channel material. This offering a potential alternative to conventional silicon-based transistor. Carbon nanotube was first discovered in 1991 by Susumu Iijima at ENC, marking a significant breakthrough in nanotechnology. The first basic CNT fab was demolished in 1998 by depositing a single-wall carbon nanotube CW-CNT from a solution into outside silicon substrate. CNT FET exhibits several advantages over a traditional CMOS technology, including a high carrier mobility, excellent electrostatic control due to their one-dimensional structure, and the ability to operate a low voltage. Those characteristics enable CNT FET to deliver high performance, low power consumption, and high power density, making them an ideal candidate for the future nanoscale integrated circuit. As a transistor scaling property is physical limit in silicon technology, CNT FET are beginning actively research as a next generation solution for the energy sufficient and high density electronic device. So the carbon molecule can group into the 5 types, which are the graphite, diamond, fluorines, and carbon nanotube. The graphite is a single layer of carbon atom arranged in a two-dimensional honey-bond lattice. It also known as its expectation, electrical, thermal, and mechanical property. A graphite consists for multiple layers for graphite stacked on top of each other. Typically, it has more than 10 layers. The layers are fused together by the weak van der Waals force, allowing them to slide easily, which making the graphite a lubricant in a conductor. The next is a diamond. Diamond is a crystalline form of carbon that forms under high pressure and temperature. Unlike graphite and graphene, each carbon atom in diamond are theoretically bonded into 4 other carbon atoms, giving an extreme hardness. Fluorine is a molecule made entirely for carbon, formatting a closed cage by a structure, often a spherical or cylinder. This application in material science, electronics, and nanotechnology. Lastly, we have the carbon nanotube, which is a cylindrical nanostructure formed by rolling up a sheet of graphite. CNT can be a single wall CW-CNT or the multi-wall MW-CNT, and they possess a remarkable electric, thermal, and mechanical property. So what is the CNT? The CNT is a large molecule of pure carbon that are long and thin cylinder about 0.4 to 2 nano in diameter and 2 nanometer to 5 micron long. So the structure are single wall and multi-wall. So the property are the nano range dimension, high temperature, and a low mobility for the carriers. So a single wall CNT is a single layer of graphite walled into a cylinder. The diameter around 0.4 to 2 nanometer, and the length is about 0.2 nanometer to 5 micrometer. So the band gap range is about 0 to 2 eV. So the conductivity has materialistic or semiconductor property. This popular use in a nanoelectronic application like a nanowire and a CNT FET. For the multi-wall CNT, consists of multiple raw layers of graphite or a single sheet on the graphene rod around itself. So the distance between each layer is around more than 3.5 angstrom. So it is usually zero gap and metal property around this material. So this is good for the nanomechanical device and triple wall armchair CNT. For the charity of the CNT, the CNT normally is a hexagonal orientation and the diameter of the nanotube determines its property. The chiral vector is defined as a CH equal to Na1 and Na2. The distance between the atoms is 1.2 nanometer. The different n property will give a different dimension of the CNT. Example for the zigzag N0 in the 3n of form A1 vector will make a metallic and other form take a semiconductor property. For the armchair n equal to m, always a metallic property, and for the chariot nm, conductive property depends of the CH. So how the CNT created? There are two methods. The first one is the chemical vapor deposition (CVD). CVD is achieved by taking a carbon source in the gas phase and during an energy source, such as a reciprocity heat coil, to transfer energy to gaseous carbon molecule. The hydrocarbon then flow to the contact tube and at a high temperature to break the Hc bond to produce a pure carbon. The next is the arc discharge. The use of the two graphite rod and one anode and one cathode at the 1 millimeter apart, placed in a low pressure inner gas. The MOS nanotube disposed on the cathode when the rod electrode keep at the different potential and arcs. The first CNT FET was fabricated in 1998. The CNT FET have three terminals, which are the source, gate, and drain. When the gate is on, the current transmitted from the source to the drain through the semiconducting CNT channel. The segment between the drain and source gate is heavily doped to provide a low resistance. So how the CNT FET operate? The CNT operate by controlling the flow of the current between the source and the drain electrode by modulating the charge within the nanotube channel using a gate electrode. The key difference in this is use of carbon nanotube, which can exhibit a plastic transport, which can minimize the sketching of electrode, leading to the potentially superior performance for the silicons. So how many CNT types? Based on the geometry, they can group into the three: top gate, bottom gate, and coaxial gate. Based on the operator, you also have the Shockley barrier and ohm barrier like the MOSFET. So the right side is the first CNT FET fabrication. By depositing a single wall of CNT that synthesis by the laser ablation form a solution into oxide silicon wafer, which can be patterned with a gold or platinum electrode. There are some CNT geometry type. The CNT FET geometry type contain a back gate, top gate, round and suspended gate. The back gate is the basic generation, shown in high on-state resistance, low transconductance, and no current saturation profile. Then the second generation of CNT FET came in the top gate structure to improve the performance. Then for the next generation is a round to achieve a more electrostatic control over a channel. And the last one is suspended gate, which is currently on use. Then this is a diagrams of the Shockley barrier and the ohmmetric characteristic between the MOSFET and CNT FET. Since the two have a different property, the off state and the on state for these two is different in the graph. So for the IDS characteristic, the IDS current is determined by the Fermi-Terry probability distribution, where the d is the density of the state of at the channel, the ns is the velocity state field by the source, and the nd is the velocity state field by the drain. So for this one, you will get the F equal to ET, then bias dependent carrier injection determined by the status between the source drain and the Fermi level. So for the VE is a carrier Fermi velocity and the TE is a transmission at the contact. So for the last one is the DE is a charge in the channel. So this one you will get the incurrence for this one. Yes. For the NP polar CNT FET, it's a backgate type M-type CNT FET can be achieved by doping the CNT with the potassium. The shift the Fermi level from the valence band H to the conduction band H by transferring the electron from the potassium atom to the CNT. This immediately state where both electron and holes are allowed to be an hyperpolar function conduction. For the CNT FET fabrication, the CNT FET fabrication normally synthesis using a CVD. So when the CNT are synthesized, we need to place into a substrate into a substance. So the first one is a dielectrophotolysis DEP. The voltage applied to electrode in a substrate causing the CNT align through the electric line. So this technique will effectively place an individual CNT with the precision. So then we continue with the speed coating. The speed coating is a CNT dispensed into a solvent and spin coated into a substrate. This method is more suitable for the large-scale uniform CNT film but may result in the less precise alignment. Then we will continue with the CNT transfer. The CNT grow separate substrate are transferred in the main individual causing this technique like a dry transfer or wet transfer. The CNT will selectively grow in a specific region for the substrate using a lithography defined catalyst pattern. So when the photoresist layer is applied to the substrate, the pattern using the ultraviolet light exposing the area where the source and the drain electrode will be formed. Then we will form a contact for the both sides. Then we will get the gate like electricity to connect each of the gate. So for the metal deposition, metals such as gold, platinum, titanium are then deposited into a substrate using a technique like processing or e-beam evaporation. The metal is deposited selectively to form a source drain or electrode. Therefore, after the deposition, the photoresist left behind the metal source and the drain contract. So with the thin dielectric layer will form between from the side view we can see from the CNT is formed from the contact and the dead gate dielectricity. So the VI characteristic we can see in the graph. So the ambipolar in the VGS is equal to the VDS over 2. So the ambipolar point independent to the SB. So for the IDS is independently on the diameter and the temperature. So depends on these two graphs. The IDS is depend on the larger of the diameter, the highest of the IDS. So also same for the temperature. For the highest temperature, also larger for the IDS. So as a summary, the CNT FET provides a dense, high performance and low power circuit. It is a rapidly developing technology due to its outstanding electrical characteristic. So in the theory, the CNT FET have the potential to reach a technical charisma when compared to the standard semiconductor technology. Nevertheless, this field is still at an early stage, and as for a long time beginning, the research should be remain focused on the lowering the process variation. So the technology advance such as 5G network increase the pressure to improve the smartphone battery life, spectacular efficiency, and more. This is some reference we can found in the internet as we can refer as a CNT FET. Thank you.